Very good afternoon to all the listeners. Myself Dr. Jaskaran Singh Puller. I am working as Associate Professor Mathematics in the Department of Applied Sciences, Mehmet Mulot. The topic on which I am going to deliver my lecture today is the defined T ratios, trigonometric identities with problems and elimination. This topic is related to the polytechnic students, diploma students of first semesters. So, we have to discuss the how the trigonometric function, that is, or the circular functions cos theta, sin theta, tan theta, cotangent theta, secant theta, cosecant theta, how these circular or trigonometric functions are derived. What is the basis of these trigonometric functions? So, first we will discuss about the trigonometric ratios. So, that how we can derive these trigonometric ratios, that is how we can find the sine of the angle theta, or how we can derive the cos of angle theta, or how we can derive the tan of angle theta. Basically the trigonometric ratios or circular functions are the acute angles of theta. This is the ratio of 2 out of 3 different sides of a right angle triangle. So, in this diagram we have the right angle triangles OMP, OMP, OMP is all. So, for this we can take two axes x dash OX axis and y dash OY axis of two mutually perpendicular lines intersecting at O. The revolving line OP starting from OX, this is revolving line OP starting from OX, trace out the angle XOP theta. This angle XOP is theta, where theta may lie in the any quadrant, that is theta may lie in the first quadrant, theta may lie in the second quadrant, theta may lie in the third quadrant, or theta may lie in the fourth quadrant. So, the trigonometric ratios or circular functions are the ratio of two sides, any two sides, maybe this is hypothesis over opposite sides, this is opposite side over hypothesis. So, the trigonometric ratios are 2 out of 3 different sides of a right angle triangle. The trigonometric ratios are on the basis of these are the 3 sides are say OP, OM or MP. So, trigonometric ratios will depend upon basically 2 out of these 3 sides of a triangle. So, firstly we can take the ratio MP by OP, that is MP is the opposite side and OP is the hypothesis. This ratio MP by OP side, this is called the sine of angle theta and it is written as sine theta. So, MP by OP is the sine theta. Same way the ratio OM by OP, that is OM is this side, OM is the adjacent side and it will be divided by hypothesis OP. So, this is the cosine of angle theta. This is OM by OP is the cosine of angle theta and it is written as cos theta. So, MP by OP is the sine theta, sine of angle theta and it is written as sine theta, and OM by OP is the cosine of theta and it is written as cos theta. And then ratio MP by OP, then ratio MP by OM, ratio MP by OM. So, this is MP and this is OM. So, this is opposite side by adjacent side and this is the tangent of angle theta and it is written as tan theta. So, basically we have 3 functions: sine function, cosine function and tangent of angle theta. Rest of the functions we can derive out from these 3, because we know secant theta is 1 over cos theta, we know cosecant theta is 1 over sin theta and cotangent theta is 1 over tan theta. So, MP by OP is sin theta, OM by OP is cosine theta and MP by OM is the tangent theta. Then we have ratio OM by OP, that is we have adjacent side by opposite side. This is called as cotangent of angle theta and it is written as cot theta. So, basically cot theta is the reverse of angle tan theta. Then we have ratio OP by OM. This is that is hypothesis by adjacent side, hypotenuse by adjacent side, and it is written as secant of this is the secant of angle theta, and it is written as secant theta. So, hypotenuse over adjacent side is the secant theta. Then we have ratio OP by MP, that is this is hypotenuse by opposite side. Hypotenuse by opposite side, it is called as cosecant of angle theta, and it is written as cosecant theta. So, cosecant theta is the reverse of sin theta, secant theta is the reverse of cos theta, and cotangent theta is the reverse of cot theta. Then we have 5 fundamental formulas between t ratios of any angle. So, for any angle theta, we have to prove that cosecant theta is 1 over sin theta, secant theta is 1 over cos theta, cotangent theta is 1 over tan theta, and tan theta is sin theta over cos theta, and cot theta is cos theta over sin theta. So, for this we can take this figure. So, OP is the revolving line. It will starts from OX and trace an angle XOP is equal to theta, where theta may lie in any quadrant from this point. From this point P, we can draw perpendicular PM on this line XOX dash. This is XOX dash. So, from right angle triangle, this OMP is the right angle triangle, this OMP is the right angle triangle. We have sin theta is MP by OP, and we have cosecant theta is OP by MP. When we can multiply these two equations, that is when we can multiply A by B, so we have sin theta into cosecant theta, it is MP by OP into OP by MP. So, this shows that sin theta into cosecant theta is equal to 1, or we can write cosecant theta is equal to 1 over sin theta. So, hence we can prove first part, that is cosecant theta is equal to 1 over sin theta, or we can write this as sin theta is equal to 1 over cosecant theta. So, in other words, we can say that cosecant theta and sin theta are the reciprocals of each other. Similar way, again we can take the right angle triangle OMP, and we can, in this triangle we have cos theta is OM by OP and secant theta is OP by OM. When we can multiply these two equations A and B, so we have cos theta into secant theta. So, we have cos theta into secant theta, that is this will be equal to OM by OP and into OP by OM, that is this is equal to 1. So, therefore, we have to prove that cos theta into secant theta is equal to 1, or we can write secant theta is equal to 1 over cos theta, or cos theta is equal to 1 over secant theta. So, therefore, in this we have to prove that cos theta and secant theta are reciprocals of each other. In other words, we can say that secant theta and cos theta are the reciprocals of each other. Then we can prove the same type of relation for tan theta. We know tan theta in the right angle triangle OMP, tan theta is MP by OM, and cot theta is OM by MP. So, on multiplying both two equations, this we can write on the basis of our definition, that is how we can define the function tan, how we can define the cot functions. When we can multiply these two equations, multiplying A by B, so we have tan theta into cot theta, this is equal to MP by OM into OM by MP, that is this will be equal to 1. So, therefore, we have to prove that tan theta into cot theta is equal to 1, or we can write cot theta is equal to 1 over tan theta, or we can write tan theta is equal to 1 over cot theta. So, therefore, by this we have to prove that tan theta and cot theta are the reciprocals of each other. Same way we have to prove for sin theta and cosecant theta and cos theta and secant theta. So, we know कि sin theta is mp by op and also we know cos theta is om by op and tan theta is mp by om. So, therefore, on dividing sin theta by cos theta, it will be equal to mp by op into om by into op by om, because cos theta is om by op. So, on dividing sin theta by cos theta, this will be equal to mp by op into op by om, that is it will be equal to mp by om, and which will be equal to tan theta. So, therefore, sin theta by cos theta is equal to tan theta. So, in this way we can derive tan function by knowing sin theta, by knowing cosine of theta, by knowing sine of theta, we can derive the tan function. So, in other words, we can say that tan theta is the quotient of sin theta and cos theta. Then we can, so in the last part we can write sin theta by cos theta by reversing that, that is we can write cos theta by sin theta. We know that cos theta is om by op and sin theta is mp by op. So, therefore, cos theta by sin theta is equal to om by mp, and which is by definition is equal to cotangent of theta. So, therefore, cos theta by sin theta is equal to cotangent of theta. So, therefore, in other words we can say that cotangent theta is the quotient of cos theta and sin theta. So, therefore, cot theta or cotangent theta is the quotient of cos theta and sin theta. So, therefore, all these relations first, second, third, these are the reciprocals, because sin theta is equal to 1 over cosecant theta or cosecant theta is equal to 1 over sin theta, and cos theta is equal to 1 over secant theta or secant theta is equal to 1 over cos theta, and tan theta is 1 over cot theta, and the relation fourth and fifth are called quotient relations. So, first, second, third are the reciprocal relations, and relation fourth and fifth are quotient relations, because tan theta is sin theta by cos theta, that is tan theta is the quotient of sin theta and cos theta, and cotangent theta is the quotient of cos theta by sin theta. So, last two are the quotient relations and first three are the reciprocal relations. So, now we can prove trigonometric identities. In this right angle triangle, by Pythagoras theorem we know that OM square plus MP square is equal to OP square. So, in the right angle triangle OMP, using Pythagoras theorem we can write that OM square plus MP square is equal to OP square. So, first trigonometric identity we can prove sin square theta plus cos square theta is equal to 1. So, we can divide OM square plus MP square is equal to OP square by OP square. On dividing this, we can write OM square by OP square plus MP square by OP square is equal to 1. Or we can write this as OMP by OP whole square plus MP by OP whole square. So, we can write this as OM by OP whole square plus MP by OP whole square. And by definition of sin theta and cos theta, we know that OM by OP is cos theta and MP by OP is sin theta. So, therefore, cos theta whole square plus sin theta whole square is equal to 1, or we can prove that cos square theta plus sin square theta is equal to 1, because this is by definition we know sin theta is equal to MP by OP and cos theta is equal to OM by OP. So, therefore, we have to prove first trigonometric identity, that is sin square theta plus cos square theta is equal to 1 always. And also from this result we can prove that sin square theta is equal to 1 minus cos square theta, or we can write cos square theta is equal to 1 minus sin square theta. So, in the next part we can prove that secant square theta plus secant square theta is equal to 1 plus tan square theta. Again we can use first equation and we can divide first equation on both sides by OM square. So, on dividing we can get OM square by OM square plus MP square by OM square is equal to OP square by OM square. or we can write this is equal to OM by OM square is 1. So, 1 plus MP by OM whole square and is equal to OP by OM whole square. So, MP by OM by definition that is equal to tan theta. So, it will be MP by OM is tan theta whole square and OP by OM is secant theta. So, it is equal to 1 plus tan theta whole square is equal to secant theta whole square. This is by definition. This is by definition secant theta is OP by OM and tan theta is MP by OM. So, therefore, 1 plus tan square theta is equal to secant square theta, or secant square theta is equal to 1 plus tan square theta. Also from this result we can write secant square theta minus tan square theta is equal to 1. This is secant trigonometric identity. And also we can write tan square theta is equal to secant square theta minus 1. Next trigonometric identity we can prove that cosecant square theta is equal to 1 plus cotangent square theta. So, again we can divide equation first by MP square. On dividing first equation by MP square, we can get OM square by MP square plus 1 is equal to OP square by MP square. And we know that OM by MP square is cotangent theta and OP square by MP square is cosecant theta, or we can write this as 1 plus OM by MP square is equal to OP by MP whole square. By definition of trigonometric ratios, we know that OP by MP is cosecant theta and OM by MP is cotangent theta. So, therefore, 1 plus cotangent theta whole square is equal to cosecant theta whole square. So, 1 plus cot theta whole square is equal to cosecant theta whole square. So, that is 1 plus cot square theta is equal to cosecant theta whole square, or from here we can write cosecant square theta minus cotangent square theta is equal to 1, or also we can write cot square theta is equal to cosecant square theta minus 1. Now, we have to do the problems on the basis of these formulas, that is on the basis of trigonometric ratios, T ratios or circular function, that is on the basis of cos theta, sin theta, tan theta, then secant theta, cosecant theta, then cotangent theta, and also using these trigonometric identities, that is sin square theta plus cos square theta is equal to 1, or secant square theta minus tan square theta is equal to 1, or cosecant square theta minus cotangent square theta is equal to 1. We have to solve the problem. So, our first problem is secant theta minus cos theta is into cosecant theta minus sin theta is equal to 1 by tan theta plus cot theta. We have to prove this part. So, we can take left hand side, that is we can take secant theta minus cos theta into cosecant theta minus sin theta. So, to secant theta we can write 1 over cos theta, and to cosecant theta we can write 1 over sin theta. So, secant theta is 1 over cos theta and cosecant theta is 1 over sin theta. In the first bracket we can take cos theta as a LCM, and in the second bracket we can take sin theta as a LCM. So, it will be 1 minus cos square theta over cos theta, and second bracket is 1 minus sin square theta over sin theta. So, 1 minus cos square theta is sin square theta and 1 minus sin square theta is cos square theta. Here we can use trigonometric identity. So, therefore, it is equal to sin theta into cos theta. It is equal to sin theta into cos theta. So, over left hand side on solving we can get that is equal to sin theta into cos theta, and now we can solve right hand side. So, for solving right hand side we can write tan theta by sin theta by cos theta and cot theta by cos theta over sin theta. So, we can take LCM as a cos theta sin theta. So, it will be sin square theta plus cos square theta, and we know that sin square theta plus cos square theta is equal to 1. So, therefore, our right hand side is also equal to sin theta cos theta, and our left hand side is also sin theta cos theta. So, therefore, both sides we have to prove equal. Our second example is we have to prove that 1 plus sin theta into 1 plus cos theta into secant theta minus 1 into cosecant theta minus 1 into cot theta plus tan theta is equal to 1. We can take left hand side and we can write all secant as 1 over cos, cosecant as 1 over sine, cot as cos over sine, and tan as sine over cos. So, in this we can do, see, we can write secant theta as 1 over cos theta, we can write cosecant theta as 1 over sine theta, we can write cot theta as cos theta over sine theta, and we can write tan theta as sine theta over cos theta. And in the next step we can take here LCM as a cos theta, we can take here LCM as a sine theta, and we can take here LCM as a sine theta cos theta. So, it will becomes 1 minus cos theta, it will becomes 1 minus sine theta, and it will becomes cos square theta plus sine square theta. And by trigonometric identity we know that cos square theta plus sine square theta is equal to 1, and 1 plus sine theta and 1 minus sine theta, using a plus b, a minus b, it will be 1 minus sine square theta and divided by sine theta, and 1 plus cos theta and 1 minus cos theta, using a plus b into a minus b is equal to a square minus b square, is 1 minus cos square theta over cos theta, and the second one is 1 over sine theta by cos theta, because we know cos square theta plus sine square theta is equal to 1. So, it will be, and also again using trigonometric identity, cos square theta plus sine square theta is equal to 1, we write 1 minus sine square theta is equal to cos square theta, and 1 minus cos square theta is equal to sine square theta. So, all this will be sine and sine square, this will be cos and cos square, so all will be cancelled, and finally this is equal to 1, and that is our right hand side. In this question we have to prove that 1 plus sine theta into 1 plus cos theta into secant theta minus 1 into cosecant theta minus 1 into cot theta plus tan theta is equal to 1. Our next example is, if sine theta plus cos theta is equal to 1, then what is sine theta? So, for that we can scaring both sides. On scaring both sides, so we have to given sine theta plus cos theta is equal to 1. On scaring both sides, sine square theta plus cos square theta plus 2 sine theta cos theta is equal to 1, that is by applying a plus b whole square. And we know that by trigonometric identities, cos square theta plus sine square theta is equal to 1. So, therefore, 1 plus 2 sine theta cos theta is equal to 1, that is 2 sine theta cos theta is equal to 0, or we get sine theta is equal to 0, because 2 sine theta cos theta is equal to 0 means sine theta cos theta is equal to 0, that is sine theta is equal to 0. Then our next example is, we have to prove that tan square theta minus sine square theta is equal to tan square theta sine square theta. So, we can take left hand side, we can write tan theta as sine theta by cos theta. The tan from tan square theta, it is sine square theta by cos square theta. So, we can take sine square theta common, it is 1 over cos square theta minus 1, and we can take cos square theta as a LCM, it will becomes 1 minus cos square theta, and we know 1 minus cos square theta is equal to sine square theta. So, it will be sine square theta into sine square theta by cos square theta, and sine square theta by cos square theta is tan square theta. So, therefore, we get the result sine square theta into tan square theta. So, that is our left hand side, that is our right hand side, that because in this question we have to prove that tan square theta minus sine square theta is equal to sine square theta tan square theta. This is our right hand side. So, our next example is, we have to prove that under root of secant square a plus cosecant square a is equal to secant a into cosecant a. So, in this we can write secant as 1 over cos and cosecant as 1 over sine. So, it will becomes 1 over cos square a plus 1 over sine square a, and we can take cos square a and sine square a as a LCM. So, this will becomes under root of sine square a plus cos square a, and by trigonometric identity we know that sine square a plus cos square a is equal to 1. So, this will be equal to 1 over under root sine square a cos square a, and we know that 1 over sine square a is cosecant square a and 1 over cos square a is secant square a. So, this will be equal to under root of secant square a plus cosecant square a, that is this will be equal to secant a plus cosecant a, and that is our right hand side in this. So, in this question, In this example, we have to prove that under root of secant square a plus cosecant square a is equal to secant a and cosecant a. Our next example is we have to prove that cot theta plus cosecant theta minus 1 over cot theta minus cosecant theta plus 1 is equal to 1 plus cos theta over sin theta. We can take left hand side and we can write cot theta as cos theta over sin theta and cosecant theta as 1 over sin theta in this example. Or another method is we can put the value of 1. We can put the 1 as a trigonometric identity because we know that cosecant square theta minus cot square theta is equal to 1. So, in the numerator we can put 1 equal to cosecant square theta minus cos square theta, and cosecant square theta minus cot square theta we can using a square minus b square is equal to a plus b and a minus b. So, we can write cosecant square theta minus cot square theta is equal to cosecant theta plus cot theta into cosecant theta minus cot theta, and we can take cosecant theta plus cot theta common. So, it will be equal to 1 minus cosecant theta plus cot theta. So, these two 1 minus cosecant theta plus cos theta, and this is also same, that is 1 minus cosecant theta plus, so these two are cancelled and this will be equal to cosecant theta plus cot theta. Now, to this cosecant theta we can write this as 1 over sin theta, and this cot theta is cos theta over sin theta, and sin theta is our LCM, and sin theta is our LCM. So, this will be equal to 1 plus cos theta over sin theta, and this is equal to right hand side, and this we have to prove in this example. In the next example, our next example is we have to prove that 1 plus cos theta over 1 minus cos theta under root is equal to cosecant theta plus cot theta. So, we can take left hand side and we can rationalize the denominator, that is we can multiply numerator and denominator by 1 plus cos theta. So, therefore, we can multiply numerator and denominator by 1 plus cos theta. So, this is 1 plus cos theta into 1 plus cos theta over 1 minus cos theta into 1 plus cos theta. So, numerator is 1 plus cos theta whole square and denominator is 1 minus cos square theta, and by using trigonometric identity we know that 1 minus cos square theta is equal to sin square theta. So, it will be 1 plus cos theta whole square over sin square theta under the root. So, this will be equal to 1 plus cos theta over sin theta, and we can divide this this will be equal to 1 over sin theta and plus cos theta over sin theta. We know 1 over sin theta is cosecant theta and cos theta over sin theta is cot theta. So, this we have to prove in this example, that is in this example we have to prove that under root of 1 plus cos theta over 1 minus cos theta is equal to cosecant theta plus cot theta. In the next example, we have to prove that sin a over 1 minus cos a is equal to 1 plus cos a over sin a and is equal to cosecant a plus cot a. So, first in this example we have to prove that these two are equal, that is we have to prove that sin a over 1 minus cos a is equal to this. We have to verify this identity, then any one of the part we can take equal, that is we can either we can take sin a over 1 minus cos a, and that is we have to prove that this will be equal to cosecant a plus cotangent a, or we can take 1 plus cos a over sin a and we can prove this will be equal to cosecant a plus cot a. So, therefore, we can take first two part, that is we can take sin a over 1 minus cos a is equal to 1 plus cos a over sin a. We can cross multiply these two, that is we have sin square a is equal to 1 minus cos square a, or sin square a plus cos square a is equal to 1, which is true because this is trigonometric identity. So, therefore, sin a by 1 minus cos a is equal to 1 plus cos a by sin a. So, now we can take first part, that we can take 1 over cos a over sin a. We can divide separately 1 by sin a and cos by sin a. So, this will be equal to 1 by sin a plus cos a by sin a, and 1 by sin a we know 1 by sin a is equal to cosecant a and cos a by sin a is equal to cotangent A, and which is our right hand side, that we have to prove. So, therefore, similarly we can write sin A over 1 minus cos A is equal to 1 plus cos A over sin A, and is equal to cosecant A plus cotangent A. Our next example is we have to prove that cos theta over 1 minus tan theta plus sin theta over 1 minus cot theta is equal to cos theta plus sin theta. So, to prove this, we can take left hand side and we write tan theta is equal to sin theta by cos theta, and we write cot theta is equal to cos theta by sin